This is problem 1 for the EECE 321 midterm. Um, so this sigma delta analog to digital converter, it's made up of a comparator, an integrator, another comparator, a D flip-flop, and this D flip-flop is clocked much faster than the system clock, and we'll get to why that is. So first, let's look at what happens when x in is 0. When x in is 0, we know that this node x4, it's, because it's the output of a comparator, it's always going to be positive rail or negative rail. So if x in 0, the two possibilities for x2, again, is going to be just positive 5, negative 5. And the integrator, how this works is it's its last value plus x2 with the sign also. So, it's going to be x3 last plus or minus whatever x2 is. And you can kind of see that if this was plus 5 last, then this right here is going to be something plus 5. We don't know what x3 last is, but we can confirm that after enough time, anything plus 5 after enough time is always going to go positive. So that's what happens, is that x3 is going to go positive. It's going to be greater than its ground reference. So this rail is now going to go positive. So now we have 0 minus 5, so x2 goes negative. And again, x3 last, no matter what x3 last was, if we're constantly subtracting 5, it's eventually it's going to go below negative, or go below 0. And so what happens is basically we get a bunch of logic high and logic lows, and this is all getting clocked into this flip-flop. And when x in is 0, we're going to get a perfect 50% duty cycle at x4. And again, this is getting clocked and fed into the system. So now let's look at what happens when x in is positive 4. So when x in is positive 4, there's two possibilities for x4 node. We can see that the two possibilities, when x in is 4, there's two different possibilities for the x2 node, and those are positive 5 and negative 1. So now let's look at x3. So if we know that x3, its next value is going to be x3 last plus x2. And when x in is 4, our two possibilities for x2 is going to be positive 5 and negative 1. So we can see that we're going to reach if x3 happened to be negative, its transition from negative to positive is going to happen faster than if x3 was, I'm getting tongue-tied, than if x3 was positive. Because, anything minus 1 and then anything plus 5, you can see that we're going to make a negative to positive transition faster than a positive to negative transition. So when that transition does happen, it's going to show up on x4 and the cycle is going to repeat itself. Yeah, so again, we've established that x3 is going to be positive more often than it's negative. And what are the implications on the x4 node? It pretty much means the same thing because it's a comparator with ground. So it means that x4 will also be positive more often than it is negative. And so as this flip-flop right here is getting clocked, our duty cycle, remember it was 50% when x in was 0? Our duty cycle, because x4 is positive more than it is negative, we know our duty cycle is positive, or our duty cycle is going to be greater than 50%. It'd probably be like, it's going to depend on the integrator and the capacitor and the feedback loop and all these things. But this is more of a qualitative approach, but we can also make the argument that as x in becomes more positive, the duty cycle at x4 is going to become greater, even more than the initial one. And then if x in is negative 4 or a negative value, the same process is going to go, but the equation that determines this x3 node, the negative part is going to be greater. So the transition from positive to negative will happen faster than the transition from negative to positive. So that means that when x in is less than 0, then x4 is going to be spending more time. Also, x4 is going to be spending more time as a negative number. So our duty cycle, we're going to have more logic lows than logic highs. That means our duty cycle is going to be less than 50%. So you can kind of see how the value on x in is represented as the duty cycle between logic lows and logic highs at the x4 node. So that is kind of a quick rundown on how a sigma delta analog to digital converter works.